Chapter 10, the mole. New concept to you guys in chemistry. You did not have this your freshman year. We're going to talk about how to use this concept to talk about lots of quantities of small, very small things, such as atoms.
Right.
She laughs at me. Measuring matter. What are the types of particles? We need to discuss these four major types. You should already know all of them.
Right.
We've got atoms that are coming off your periodic table, ions that have a charged particle, either positive or negative. You've got formula units. This might be a new term, but it's just another name for ionically bonded compounds. So instead of compounds, you're going to hear formula units. And then our fourth type is molecule, which are covalently bonded. Atomic mass is the average of all the protons and neutrons of every single isotope. You've got this on your periodic table. It is a decimal number. We label it an AMU for this beginning portion of the chapter, but we're going to change it here in a little bit when we talk about molar mass. But Mrs. Kelly, I have a question for you.
What?
Your formula mass or atomic mass, do you use decimals or whole numbers?
If I'm trying to figure out neutrons, I would round it.
Okay. So
but if I do these calculations, then I leave it as decimal.
You leave it as decimal.
Yeah, what do you do?
I use whole numbers.
Okay.
So we're going to have just a little bit of differences here. We'll go through possibly with the decimal numbers and show you this one, and then my class we can round. The answers are going to be really close to each other.
Yeah.
It just depends on preference of the teacher. So live with it. Measuring atomic mass unit for carbon, we're going to look on our periodic table, and what we're going to find is what its mass is, and we're going to round it off to a whole number in this part, so it's going to be 12. I got that one.
I have that one, yeah.
Yeah, we hope. Oxygen, we're going to look on our periodic table, and we're going to find out its mass is 16.
Yeah, so it's either 15.999. I've also seen it as 16.0001. So 16.
Yeah, that's why I round.
It's close enough.
Formula mass is the sum of all the atomic masses of a compound or a molecule. So you have to add these pieces up.
Yes.
So if we find hydrogen, hydrogen has 1 as its mass.
Yes.
And there's 2 of them, so that would be 2. Plus oxygen, which has 16, which then gives us a total of 18 AMU. So formula mass has the label of AMU. Now this big monstrosity down here, manganese,
Carbonate?
yeah, that'd be good. I think I need to take a nap. Yeah, manganese carbonate.
We don't know which manganese we're talking about, though.
Oh, manganese 3.
Yes, it would be manganese. Okay.
So we need to add up all these pieces, and I worked a little bit ahead in my notes, so I have all of these ready to go.
Okay.
We've got
Manganese.
55.
Oh, come on. 55.
Its mass is 55, and there are 2 of those.
Yes.
Plus carbon, which is 12, and there's 3 of those.
Okay.
And oxygen is 16, and there's 3 of those. So once we plug all that into our calculator, we find the total mass is 194 AMU, atomic mass unit. Yay!
You
Pretty
have
good.
to know how to do that.
Oh my goodness,
If you don't know how to do this, ask us like the first day because this is so important.
Yeah, this is going to be huge. So what's a mole? Here's a little history lesson. Are you ready?
Ready.
I love history. Atoms are way too small for us to weigh a single one. We just don't have it. You can't just take one little atom and put it on a scale. So what scientists did is they measured several atoms of the same element. The first one was Mr. Avogadro, who gets credited for all of this wonderful math, and it's his number.
Avocado.
Not avocado, no. Which makes really good guacamole. But no, it's Avogadro. He used carbon-12, and he weighed out 12 grams of it. Out of that 12 grams, every single time he did it over and over and over again, he found it to be 6.02 times 10 to the 23rd atoms of carbon in that group. He also did it with oxygen. He took oxygen 16, so the isotope oxygen 16 took 16 grams, and found out it was 6.02 times 10 to the 23rd. Did it with nitrogen. 14 grams of nitrogen. Every single element that he could use, he weighed out that same mass, found it to be the exact same number of atoms within that compound. So what we find is Avogadro gets his number, and we get to use it in our math from here on out. Yay!
Yay!
So we're going to find out how many particles. Now, I did research a little bit on where the mole came from. And this guy named Oswald,
Okay.
yeah, he gets credited for shortening the word molecule to mole.
Oh.
Yeah, that's all I got. Nothing too fancy. Not like he licked the little creepy things under the ground. No, he just shortened the one word to mole.
Okay.
Fabulous. That's the history. So, basic math. You have down in the bottom corner, we're giving you your first triangle. If you look on your cheat sheet, front side, way at the bottom, you're going to find this same, and I would call it a triangle, but it was hard for us to make a triangle on Word or PowerPoint, so there's squares.
Yes.
More rectangular, but you'll live.
They're there. So Avogadro's number is in the table for you. However, you will use it so frequently you'll probably memorize it.
Oh yeah, easily. So what we're going to do is we're going to plug in what's given to us, plug it into the box, and see mathematically what we're going to do.
Okay.
So the first one, if you have 2.25 moles of bromine, how many particles are you going to have? Well, the particles in the top box, that would be our x. We've got the 6.02 times 10 to the 23rd down in the bottom left corner, and we also have moles. Well, they gave us moles, so we can plug that into that bottom corner, and because they're sitting next to each other, mathematically in these little triangles, we get to multiply them together. So we're going to take the 2.25 moles times the 6.02 times 10 to the 23rd, and that will take on whatever label you need it to take on. It'll take on the atom, the ion, the formula unit, or the molecule, whatever you need.
Right.
In this case, since we're talking about bromine, and bromine's a halogen, it can't stay by itself,
Right.
so we would have Br2, which would be a molecule.
Yes.
So we're going to
Diatomic
find,
molecule.
we're going to find out what type of particle, we're going to find molecules. So after we do that math, we find it to be 0.48 moles. Right?
You don't.
No, I don't. Right here. Oh, we're doing this one. I jumped ahead.
You
See,
did.
this is what I get for reading my own notes wrong.
1.35
Molecules.
molecules.
See, I picked these long ones for you have to write out.
Thank you. And then because it's bromine and it's diatomic, we expect you to know that you need to write Br2.
Yes.
Sorry.
The 1.35 molecules, you've got to be able to pick out, is it a molecule? Is it an atom? Is it a
Yes.
formula unit? I don't give ions. Do you give ions?
Not typically.
No. It is an option, but typically in this level we won't be using those.
It would
So
be
you've
like the
got
whole
3.
formula unit.
Yeah, that we would be giving. So here's another example. We're going to go the other way. How many moles are in a sample of sodium bromide that contain 2.88 times 10? Ooh, that 23rd should be raised to a superscript. Sorry. Formula units. So we're going to have,
This should be 10 to the 23rd.
yeah, sorry, typo. Didn't
Okay.
catch that. So the particle, the formula unit is a type of particle. So that's going to go in place of that top box.
Okay.
Um,
So it's going to say moles
Yeah.
equals, and then our particles.
Yep.
2.8. Oh, I should have just marked it in there.
you should have just wrote it in that box down there.
Oh, well.
Divided by 6.02 times 10 to the 23rd. Now I'm going to read my notes right, Mrs. Kelly.
Good.
I'll get it. 0.48 moles of NaBr.
How do you abbreviate moles? Oh, that's an NA.
MOL.
Yeah, me too. Okay, so you instead of writing moles, it doesn't save you that much writing, but you could
No.
just write MOL.
But molecules, you have to write out the whole thing.
Yes, you do.
There's no shortcut for that one. Why? Don't know. Just isn't. So we've done our particles to moles and moles to particles.
And you won't have to figure out Avogadro because it's already given to you.
Yeah, it's already in that bottom corner. So you just got to know how to use your cheat sheet. We are going to keep going, and we're going to go into our 10-2, the mass in the mole. We're going to be using some more information. It's called molar mass. Molar mass is very similar to your atomic mass or formula mass, except instead of AMU, now it's gram per mole. So you're going to be adding up either calcium, which is just the element, and you're going to look it up on a periodic table. See, now I would go to 40, and you'd use 39 point something.
30. No, calcium is well up
Is it
there. It's
40.0?
40.08.
All right.
Okay, so I could do 40.
All right. It's
I'll
up
be
to you.
flexible.
Okay.
Okay.
It's less
so
writing.
40, and now our unit is going
Gram,
to be
G.
over MOL.
Yep. And then the sodium chloride, if you have a compound like this, you get to add up everybody. So you're going to take sodium, which is 23,
Okay.
and chlorine, which is 35, and you get 58 gram per mole. So molar mass, you're just going to look on your periodic table. You're going to add up everybody. And after a while, you're going to really start to memorize these because you're
Yeah.
going to use a lot of the same ones over
Like
and over
water,
again.
you'll know is 18.
Yeah. Oh, a
That's
lot
the
of them.
biggest one.
Carbon, 12, all of those. So let's use our next triangle.
Yes.
Still on your cheat sheet, front side, bottom corner. We've got grams, molar mass, and moles. Grams is on the top. Molar mass is in your bottom corner, so you will always know that because you're getting that from your periodic table. And your moles. So our very first one up here says a roll of copper wire has a mass of 848 grams. How many moles of copper are in the roll? So we've got the gram amount, 848. That's going to go on the top. And we're going to find out what the molar mass of copper is off our periodic table, and it's going to be 64. We're going to divide the two, and we end up with 13.25 mole MOL of copper, which we would say Cu. Now, notice Mrs. Kelly is labeling absolutely everything, not only just the mole, but also giving what element or compound we're dealing
You
with.
have to do that.
You have to designate what we're talking about every single time.
These calculations can get really complicated. So it's not only going to let us know what you're talking about, but when you go back to study or when you go back to correct a mistake, you'll know what you're talking about.
Yeah, you'll have it labeled. You'll know. We can easily then look, you didn't use the right molar mass.
Yeah,
Divided instead of multiplied, whatever you needed to do.
it's really important to label.
All right, so calculate the mass. So the next question. Calculate the mass of 0.625 moles of calcium. So now we know the moles, and we want to find the mass. So we're going to take the molar mass, and we are going to multiply it by the moles. So 0.
Oh, oops.
You
Wait,
did another
I
math
did it
problem?
wrong. Yeah.
Here, just plug it in down there
I
in the
do
box.
have an erase, but
Yeah.
whatever. Okay, so what am I going to do? I'm going to do
Yeah,
it down
just-
here.
Yeah, plug it
Where
in that
am I?
box down there.
Okay.
You got the 0.625 moles, and then the molar mass of calcium is 40. And because they're sitting next to each other, we can just multiply, and we get 25 grams of Ca. There you go. We've used our two triangles. Do you think they are ready to use them both?
I don't know.
Well, too bad. You're going to. So now we're going to combine the two triangles, and we're going to solve for one. Jump to the moles, because moles is the same variable in both of these two triangles.
Mm-hmm.
So in this first calculation, we're going to calculate the number of atoms in 4.77 grams of lead.
Okay.
So if we know grams, we want to find the number of atoms. They are not in the same triangle. We've got to figure out what can we use to move between them.
Check out, we've got moles here. Oh, that's a good circle. And moles here.
All right, so we're given grams. So which triangle are we going to use first?
The second one.
All right, so we've got 4.77 grams of lead, which is PB, off not peanut butter and jelly, but your decimal is very tiny.
I know, but if I draw a circle, it
Oh, that's
sends
true.
me to the other screen. Okay, what is the molar mass of lead?
You know what? I don't use that one enough. I'm gonna have to look it up. 207. If we've got 207 gram per mole, it doesn't like circles, does it?
No.
207 gram per mole. We divide those, and we end up getting 0.023 mole PB. So
Okay, if you're
now-
like me
Yeah.
and you like to label in your equation,
Yeah.
you'll see this is gram and it's divided by gram, and then you have mole on the denominator of the denominator. So really, it's going to be
Bump
what
to
your
the
unit
top.
is at the top.
Yep.
So that's how you know. I like to cross
Yep.
things out and see how it works.
Yep, gram and gram cancel, and mole gets bumped to the top.
Okay.
So now we're at moles, and we want to find the number of atoms. Well, I know atoms is a type of
Oh,
particle.
sorry.
So now I
This
can
is a
use now I can use the first triangle and plug that mole down, and we're going to multiply by Avogadro's number, 6.02 times 10 to the 23rd.
Oh my gosh. Okay. Okay.
And we end up with 1.39 times 10 to the 22nd atoms of PB. I knew that that was going to be labeled atoms because PB is a metal and it's found on my periodic table. So it's got to be just
Oh,
the
it's not
B.
palladium. Let's just do this.
Oh, PB.
Oh my gosh, I almost did it again.
B. There we go. All right, so that's using both